find in assembly. The first one is top-down approach. So what is top-down approach here? In top-down approach, you will create your component under assembly design only, and there only you will perform the assembly. Before that one, we have to understand what is assembly here. So see here, assembly is nothing is there. Whatever components we are creating, see here we are not making a thing like, for example, if you take any component, for example, I will take an example of small thing is pen. Everyone has pen. So that pen has 4 parts: refill, bottom part, up part, and refill also has nib, and nib also have one more ball. So those things we can find under that. Okay, so many parts we are clubbing into clubbing with each other, and we are making a single component. That is our assembly. That's what we can say as a assemble. Means we are assembling the things. We are taking a small component and we are assembling that thing and making as a useful component. So here also like that only in assembly, what we will do, whatever components we are creating under part design, surface design, sheet metal design, those are small components. Okay, even we can find big component also, but the thing is there we can able to find the things like no usage. Suppose for example, if you have any single component, for that one without any assembly, like without if you are creating anything as a single component, that component we cannot able to make as a movement in that one. Why? Because a single component you have to just it will like a stable component, rigid body we can say for that one. Okay, but whereas when you come to assembly design, after you are assembling the small components into a big component, those components has either it may be a rigid body or it may be a movement like movable bodies. Okay, so rigid body, for movable bodies compulsory the object has so many small components should be there. For example, I am taking an example of car also. In car also you can find n number of components. So those components we are creating separately, small components, and all the components we will call here, and all the components we will call here, and we will assemble those things. Okay, understand guys? So like that processes we are following here. The next thing is after assembly, you understand the assembly like we are clubbing the small components and making a big component by making a big component. So after that one you have to understand that what are the procedures and what are the approaches we are following here. Here in assembly design we have 2 approaches. The first one is bottom up approach, the next one is top down approach. Okay, so bottom up approach. So what is here bottom up approach? Bottom up approach means what you will do, you will create your components. Okay, you will create your components under part level like part design or sheet metal design. It is guys. Okay, where I am? Yeah, bottom up approach. See here, in bottom up approach, whatever components, small components are there now, we will design those components under part level. Part level means we have the workbenches for part level, that is part design, sheet metal design, and surface design. There we will create those components. And what we will do, see, every component, small component will create there only, but separate workbench we will open. Okay, separate workbench we will open for that thing. But whereas yeah, so I said that in bottom approach, whatever components, small components or single components are there, those things we are creating under part level. Means by entering into that environment, by entering into that workbench, we will create and we will save those parts under our libraries, and later we will enter into the assembly workbench and there we will call. That is the procedure in bottom-up approach. Whereas when you go to the top-down approach, here the thing is, here what we will do, in assembly level only, what we will do, we will create a small components also by entering into the part level from assembly only. Okay, by entering into the part level from assembly only. That is my top-down approach. Understand, guys? Hello, guys.
Yes, sir.
Did you understand what is top-down approach and what is bottom-up approach?
Sir, I left the meeting. 1 second, can you explain?
Nothing is there, guys. Sorry, nothing is there. Top-down, bottom, two approaches we will follow here to create an assembly. First approach is bottom-up approach. So bottom-up approach means we will directly enter into the part level first. Okay, we will enter into the part level. There we will create the small components and we will save that component under our library. Okay, we will save those components under our library. After saving that one, again what we will do, we will open our assembly workbench or environment and there we will call that component. That approach we can say as a bottom-up approach. Now come to top-down approach. So top-down approach in the sense, in that approach we will directly enter into the assembly first. From there onwards we will create a component by entering into the part level from there only. Okay, from there only we will enter into the part level. We are not closing our assembly workbench. We are in assembly level only. Just what we will do, we will enter into the part level from there only. Then after creating that component, again we will enter into the assembly directly from there only and we will club those parts. Means while you are working on top-down approach, you can find all the components there only. Okay, we can find all the components under assembly only. But here in bottom approach, we will create our component and we will say, wait a second, guys. Yeah. So in top-down approach, in assembly navigator only, see, when we are creating any assembly in top-down approach, we can find all the components under one assembly only directly. Means from there only we will club those parts. But whereas when you come to bottom approach, we will not see all the components on our screen. In bottom approach, we save our all components in our library. From there, one by one, we call the components and we will do assembly. That is the two approaches we can find here. Now understand the things?
Yes, sir.
Now we will enter into the assembly design. Today we will complete both the approaches. Assembly design. So now see here, the assembly design has been opened here. This two and this three. Only these three toolbars are there in this one. Okay. Anything else? Yeah, this one somewhat we can use sometimes. Okay. Now see here. This is our first toolbar in assembly. We will come to that approaches later. First, we will discuss what are these toolbars are. Here we have the first toolbar, which is very important here, that is product structure tools. Okay, product structure tool. So what is the use of this toolbar? See here the commands, whatever you are seeing here in this toolbar, all the commands are used to call your components. Okay, maximum all the parts, all the commands we are using to call the components or to create the new components. This all of. The next toolbar we can find here, that is move toolbar, or we can say manipulation. What is the use of this toolbar? With the help of this toolbar, we can able to move our objects. Okay. Okay, guys. So this toolbar, with the help of this toolbar, we can move our object from. We can move our component from one location to another location. The next toolbar we can find here is constraints toolbar. Constraints toolbar. See here how we are joining, clubbing or assembling the components. Usually when you go to the real-time environments, okay, when you go for the real-time, there what you will do, you will use nuts, bolts, and we will use some procedures to assemble the components. Like what we will do, holes to holes we will match. Okay, holes to holes. By using holes to holes we will match. By using distances we will use, and we will place the component, and we will do welding, bolts and nuts joints. By using those procedures we will follow. So see here, if it is a bolt kind of things, what we have to do in software, we can place the bolts. Okay, so before placing the bolt, we have to place our component on another. I have to place one component on the another component. Okay, like that. So if it is like that, then what it is, how to place the component? So what we will do, we will place with a mating points. We have some concept like in real time, if you go to a company, you can find some concept like mating parts, mating points we can say. So those points they will match and they will place the components on each other, like that. But here in software, those things we can say as a constraint. Okay, see here, remember you have discussed this constraint concept in the sketcher part also. So actually why we are doing constraints here? See here, every part has 6 degrees of freedom in the environment. Every part, whatever part you will take, that part has 6 degrees of freedom. So if you want to, okay, if you want to restrict those, see, if the part is free or if the part has 6 degrees of freedom, that part is free in the environment. Means wherever the part will move, it will directly move there. For example, if you go to space, there is no gravitational force there, means there is no degree of freedom, like there is no restriction of the, no restrictions are there for all the parts. That's why the part will roam in the sky anywhere. Okay, so to restrict that one, we have to give some supports to that, so that that part should not move in the space freely. Intentionally you can move, but freely it should not. So for that reason, what we will do, we will constrain, means we will stop the movement, free movement, not movement, free movement we will stop by assigning some constraints. Constraint, the meaning itself is showing constraint means restrictions. You have to specify some restrictions to that thing. So that thing is very important here. So constraint is very important here to make an assembly. Without constraints also you can able to Okay, remember this. Otherwise, what happened when we are, suppose for example, for some component you are specifying constraint, for some component will not specify the constraint. So what happens at the time? If you disturb any one part, the whole assembly is going to disturb. So whenever you are assembling the component, always follow the constraints procedure. Okay, always follow the constraints procedure. Okay guys, always follows, we have to follow the constraints procedure here. So by using the constraints only we have to assemble. Without constraint also we can able to do by moving the components, and we can directly place them at the location and we can assemble the things. But it's not a good procedure. Why? Because if you go for the company, it will like some tool is there which you can say as a checkmate. Checkmate means it will software itself check that whether the whatever objects you have created, that is a good or not, like it is a satisfied or not, it is manufacturable or not. The software it will decide. That one we can say as a checkmate. So in software they have created, they modified that software. The same software will be there. What they will do by using the customization, they will modify the software. So in that one, what they will do, they will place one checkmate there. So what checkmate will do, if you are not specifying any constraint, it will throw that error that your body doesn't have any constraint. It is free in this space. So if you disturb any one part, also the whole body is getting disturbed. So like this, they will mention them. So constraints also very important. So by usually we will use this three. Usually we will use these three toolbars only to create our assembly. Not exactly this three toolbar. From this three toolbar, see this one definitely will use constraints. Here also we will not use all the things here. Some things we will use here. Okay. Now come to the come to the approaches now. See here I said already we have two approaches: bottom up approach, top down approach. So what we will do today, we will start with the top down, which I will create my components here. Okay. So for a top-down approach, and one more thing, remember, it's not mandatory that you have to go for only top-down approach or you have to go for only bottom-up approach. You have choice, and one more thing, not only choice, one more thing you can use both the approaches for creating a single assembly. Okay, you can use both the approaches for creating the assembly. So it's not like that. So you can use according to your requirement. Now I'm starting with the top-down approach. See here you can find in product structure the first three commands are component, product, and part. Okay, component, product, and part. So what are these? See here for creating top-down approach, we have to use these three commands: component, product, part. Understand? These three options we have, these three commands we have. By using those three commands only, we have to perform the top-down approach. The next two commands you can find here, that is your existing component with positioning. These two commands we are using for bottom-up approach. The remaining, it's somewhat different commands are there. Initially the five commands we are finding here, that is the options for calling or creating the components. The remaining are different. Okay. So I said first of all we will go for the top-down approach. So for that one, the first command you can find here is component. First of all, I will explain you what are these commands. These three different commands. You have to understand the differences. First of all, I am taking component. Okay. See here, I click on the component but still not creating. Why? Because sometimes what happens, it will directly create. Sometimes what happens, it will not create. Why it is not creating means nothing is there. After taking command, if it is not creating, just click on this product one. That's it. Automatically it will create. Why? Because initially that thing is not highlighted. The product one is not highlighted. The main assembly is not highlighted. Due to which what happened, it is not creating directly. So nothing is there. Just click on the product one. It will automatically create your assembly. Okay. first one is or else slicer also you can do by selecting this one and click on this one. So slicer also we can able to do. Okay, the first one is component. See here, components we are using for creating the sub-assemblies. Okay, components we are using for creating the sub-assemblies. So what is sub-assemblies? Sub-assemblies in the same, what is sub-assembly means? It's a combination of small components we are taking and we are creating one assembly, and that assembly we are calling under big assembly. So you will say that directly we can able to call under the big assembly only, why we are creating a small assembly. This question arises. Anyhow, definitely we can able to do either also. But the thing is, suppose for example, what factor is this? Example, yeah. Take an example of pen on. Okay. Take an example of pen on. What we will do for pen? You have pen nib is there. Okay. Pen nib is there. For that nib also is an assembly. Why? Because has, we will say it has only one part, but it doesn't have only one part, it has two parts. What are those two parts? One is nib, another one is ball, which is present on the top side. With the help of that ball only we can able to write this thing. Okay? So the nib also has two parts, that is a small assembly. So that assembly will not fall directly under pen. What we will do? First of all, we will create that nib separately by doing the assembly. Then what we will do? That nib assembly we will call in the refill assembly. In refill assembly, what we will do? We have refill, ink, and that nib. Those three things we will call and make a small assembly. And that thing again we will call under big assembly, that is my complete pen, like cap and upper part of the pen, lower part of the pen. If it is a what we can say, that pen, flare pen is this we can press with the back side. So if it is like that, means we have spring and that cap, all those things are there. So those parts we can say as a higher level assembly. Okay, so this is my higher level assembly. These are my lower level assembly. So sub assemblies we can say. Okay, these things we can say as a sub assembly. So these sub assemblies also we can able to create or we can able to call. Okay, like that. Now here we have, I said component. So component we are using for creating the sub assemblies. Under that one again we can able to call the component. Under that one we can again able to create the component. Okay, small components, small parts. Okay, that is my component. Then the next term you can find here is product. Okay, the next thing is product. So product, first I will open one component, then again I will go for product. Did you find any difference between those two part names? Did you find any difference between those two names of the part? Like one I created with a component, the other one I created with the product. But when you carefully see their names, you cannot find any difference. Not on name, not on that. Everything, nothing is difference you can find here. Then what is the difference? Why we are using these two different? This is the question. Okay. So the answer is, suppose for example. Okay, suppose for example, if you are creating, see, I am taking these two as a sub-assemblies. Component and product, these two names I am taking as a sub-assemblies. Okay, suppose for example, if I am creating sub-assemblies with the help of component option, what it will do? If you are saving that file, means higher level file with the big assembly, if you are saving, whatever things you are creating under component, that is saving under big assembly only. Okay, if you are creating a sub assembly with a component option, and while saving the big assembly, the component assembly saves under big assembly only. It will not create separate file. It will not save separate file. But whereas when you go for the product, okay, whereas when you go for the product, what it will do? Not only it will save your file under the assembly, it will create some other file also. With that product name, whatever name you have to give, you can give there. So with that name, it will save a separate file also. That is the difference. Do you understand the difference? Guys, please respond.
Yes, sir. Yes, sir.
Understand the difference between component and product?
Yes, sir.
Yes. Yeah. The next thing you can find here is part. Okay. The next thing is part. So part is the small component which we are creating under part level, like part design, surface design, sheet metal design. These different designs are there now. So under that one we will create in the component. So I said that here in assembly level only we have to create a component. So for that one only we have to use this option like part. If you take this command, what happened here? It will create your part. Like if you want in this component, go here, create the part. Okay. Right. So here only we can able to create the component. Understand guys the different concept?
Yes, sir.
Yes, sir. Any doubt?
No, sir.
No, sir. Okay then. Now we will go for the next. What is next thing here? Like yeah. Like that. Now see here, I created two sub assemblies. Under the two assemblies, I created two individual parts. So you can create multiple parts. How many you want, you can able to create. Right. So how many parts you want, you can able to create. Right. Okay. Like that, we can able to create our parts. Now the most important thing, guys, how to create the components. We can able to see only the planes here. I can able to see the planes here, but I cannot find any command which is used for creating the components here. I cannot find single command also. With the help of that, we can able to create the component. Suppose for example, like we are doing in part designs, like we are entering into the part design, from part design to surface model, like that we are entering directly by using this menu option, menu bar. So like that can we do? Let's see. Now see here, I create this component, go for start, mechanical, I'm going for part design. No, it is creating a separate file. It is not adding here, it is creating a separate file, which we cannot able to use this. Then what is, then how to enter here? So nothing is there. What you have to do? Right click. Nothing is there. Yeah, nothing is there. Just double click on this part. Now see here, what are the commands you are finding here? Product structure tool, move component. When you double click on this part, automatically it will enter into the part layer. Now right now we are in part design. For example, if I want to enter into the surface design, nothing is there. When you enter into the part design, from there we can able to swap our workbenches. Surface design. Sheet metal. Like that we can swap from here. We can able to swap. And one more thing, how to identify means here you can find the highlight. Initially it is showing on the product one, this blue color highlighting, but right now showing on the part 4 means The part 4 is active now. Okay, the part 4 is active now. So whatever thing you want to create, you can create. And suppose for example, if you are in part 4 and if you are creating anything, all the things will be creating under the part 4 only right now. Why? Because this is your active work. This is your active part. If you want to create another part, means double click on that one. Now part 3 is active, part 1 is active, and part 2 is active. So like that we can activate our parts here on which part you want to work. Okay. Now after creating the part, again you have to enter into the part design, assembly design. For that one, what we have to do means nothing is just double click on this one. Then again it will enter into the part design. Understand?
Yes, sir.
Any doubt, guys?
No, sir.
Okay, then fine. Now I will create one assembly by using this assembly. Okay. See here, guys, while explaining only, I will explaining all the commands here. Like I will not take separate session for commands. Just listen carefully and see how I am doing. That is very important. Okay. Now, what I will do, I will delete both the assemblies here. Why? Because I don't want any sub assemblies here. I am creating small components. The first part I am creating here. Now see here, I entered in the sheet metal. I am going to part. Now see here, guys, I want the assembly drawing file. Right now I don't have it download that one from my. Oh, where is the file? Where I saw it? Wait a guys, I am downloading the file. Wait a second.